If I'm going to caption this talk, it is, make LLMs make sense with GraphRAG, and we'll talk about all of those words. So first off, like graphs and GenAI, they help each other, and if there's anything that I want people to leave with after listening to me talk for 20 minutes is just sort of seeing the relationship between those two things, because I don't know if you've ever noticed, but like LLMs aren't perfect. And when I talk about LLMs, I'm talking about generative AI or text generating Gen AI models. So your GPT-4s, your Claudes, your Llamas, your DeepSeeks, your insert name of generative AI model here. LLMs aren't perfect. And like, I don't know if you've ever been in the situation, I certainly have, where, I'm faced against this challenge. And maybe it's something that's, I don't know, laborious task, or it's a sort of a job that I'm not particularly au fait with, and I've been explaining it to somebody, and they've just gone, do you know what? Like Chat GPT, dude, just put it in Chat GPT, let it do the work for you. And they are fantastic productivity tools and fantastic tools for generating human-like text, and have a huge amount of potential for just making our lives that little bit easier. Never a bad thing. But if you use them for any length of time, you will find yourself in this situation. Like, just like what? Like, the thing that you've told me doesn't make sense, or it's inaccurate. And I know that for a fact, right? Why are you doing that? But it presents it as true. Because like LLMs make things up. And when they do, we refer to it as a hallucination. I think, this word hallucination has become well known. They hallucinate. But if we think about what a hallucination is, it is a statement presented as true, right? Believed to be true. It's something that's been hallucinated, right? And it's stated as fact. And it's often difficult to pick out what is true and what is not. So I love a live demo because I'm a sucker for punishment. But what I want to do is I just want to just sort of go through a really sort of simple demonstration of what I mean by this. So this is OpenAI's Playground. It is a great tool if you use OpenAI's models. It allows you to interact with models directly. I happen to be using GPT-4. It doesn't really matter which one we use for this demo, but it allows you to tweak certain features as well. But what it allows me to do is send a prompt to the LLM and get a response back, and which is exactly what I'm going to do. And I'm going to ask it a relatively simple question because I want to use this as an opportunity to demonstrate something. So I'm going to ask it, what's the weather? And it's going to respond to me with saying, sorry, as an AI developed model, I don't have real-time capabilities, and it gives me a recommendation. So this, for me, demonstrates two key reasons why large language models or generative AI models may hallucinate. So the first one is, and this is a great example of that, is it only has access to data right up until the point it was released, it was trained. They are immediately out of date. And it also only has access to data that it was trained on, typically public domain data. So if you've got private data, it's not going to have access to that. So it will, it's not going to fill in the gaps when it doesn't have data, just because it doesn't have that data. It doesn't even know there are gaps. But if I ask it, what's the weather? It's going to say, I don't know. And it represents those two issues, which is it doesn't have access to data. But it has at least come back with a response that makes sense, right? So I'm just going to change that, and I'm going to introduce a prompt. So I'm going to introduce a system message. Now, system messages are messages that are sent alongside every prompt. So essentially what I'm doing is I'm tagging this, you are a surfer dude having conversations about surf conditions on the beach, respond using surfer slang. So I'm tagging that to every question that I put to the LLM. But I'm going to ask it the same question. What's the weather? And I'm going to get back a response. Dude, the sun's out in full force. It's scoring like an 8 on the Stoke meter. Glassy sessions are lined up today for primo conditions. Right. It has provided me a human-like response, which is its job to the question that I have asked it. However, it is absolutely made up. The sun's out in force. It may be where you are. It's definitely not here. It's scoring an 8. I mean, I've no idea, even idea what that means. Glassy sessions could be, but it probably isn't. This is completely made up. However, it is presented as fact. It is an hallucination, because if we go right back to the basics of what this model is doing, is it is taking you're a surfer dude, it's taking what is the weather, and it's effectively continuing the text based on that. And that is a suitable response, albeit completely made up. But right, we can help ourselves in this. So let's try and improve this. So I'm just going to change my system prompt, and I'm going to include some additional information that tells it what the weather is. Current weather, it's calm, 3 feet waves, and it's cloudy. And I can ask it the same question: what's the weather? And I get back a response. It's pretty mellow out there, knee-high sets, 3 feet waves, a bit of grey soup in the sky, cloudy. It has provided me a human-like response that meets my requirements, but this time it is based in fact, assuming the information it's been given. And I can go further than that. So rather than just a simple sort of summary of what the weather is, I can include a surf report. So a piece of JSON that says you're a surfer dude. What's happening at Fistral. Fistral, if you don't know, is a beach in the UK, in Cornwall. What's happening at Fistral? Dude, Fistral's got gnarly 6-foot towering beast and offshore winds. Again, it's presented me with something which is now factually correct based on the information that it has been given. And again, it's used that information and it's used that prompt to create some human-like text. Okay, so let's just nip back to here. So, if you haven't seen this kind of approach before, it's called retrieval augmented generation, or RAG. RAG is an architecture, a pattern, however you want to describe it. I kind of actually prefer GAR rather than RAG. The reason being is I think it's easier to explain. Because what I'm doing here is I'm instructing an LLM to generate some text, a surfer on the beach responding to conditions that has been augmented or improved. So in this case, I've augmented it with some weather conditions or some surf conditions that by the retrieval of additional information. Now I gave it those that piece of JSON, but we can imagine that being obtained from an API or some other source. And that's what RAG is. It is providing additional information that allows our LLM to create that human-like text, which is based in fact. And going back to knowledge graphs for a moment, the reason that generative AI and knowledge graphs have been sort of paired together. If I'm going to use the analogy, it's going to be the sort of left brain, right brain analogy. So, our LLMs are incredibly good at language, reasoning, creativity, coming up with responses, but are less good at knowledge, context, and enrichment. That's our job is to give that to them. And, as we've been going on this journey, what we've found is that knowledge graphs are a really great way of providing that left brain. So knowledge, context, and enrichment to our LLMs, which are really good at the other stuff. Okay, so let's think about how, I need to just take us all back for a second and just cover off some words. So we've been talking about knowledge graphs, but what are graphs? Let's just sort of make sure everybody's on the same level. So first off, I don't mean these, right? Before I worked for Neo4J, when somebody said graph to me, I thought of these. I tend to refer to these as charts now. But yeah, I don't mean graphs. What I mean is graph theory. So edges and vertices, nodes and relationships, circles and lines. What we're talking about here is the relationships between entities, how data is connected. And Neo4j is a graph database. And if we just spend a little bit of time talking about, actually, how do you store data within a graph? So the first thing to note is that data is stored as nodes, and nodes represent things. In this case, this thing happens to be the movie Toy Story, but it could be a laptop, a monitor, a house, something abstract, an event, but they represent things, and we use labels to categorize nodes. So let's say we had 1,000 movies. They would all have their own node, and we would categorize them. We would group them together using labels. And we can have more than one label. So Toy Story is a movie, it is also an animated movie. And the way that we store data in graphs is by having properties. So nodes can have properties, as key value pairs. So in this case, the title of this node, the title property for this node is Toy Story, and it was released in 1995. But the power of graphs comes from how do we make connections between data. So let's say we have two nodes. We have the movie Toy Story, and we have the actor Tom Hanks. There is a relationship between those two nodes. And that relationship is Tom Hanks acted in the movie Toy Story, and we define relationships with types. And one of the interesting things about graphs and about how we manage data in a graph is that relationships are, for want of a better word or a better phrase, real things. And as such, we can also store properties against them. So in this case, Tom Hanks, the actor, acted in the movie Toy Story as under the role of Woody. And that's how we kind of represent data within graphs. I've lost my mouse. And graphs are everywhere. So we see graphs everywhere, from bills of materials to relationships within businesses, hierarchies, network and security management. Everywhere, anywhere where there is highly connected entities and data, you can typically express that as a graph. And really typical use cases, things like product recommendations, anti-money laundering, and subsection of that are knowledge graphs. And what knowledge graphs allow us to do is to understand the relationships typically between entities and things. So all of this effectively comes down to graph databases are designed to efficiently store and store and query networks of nodes and relationships, understanding how data is connected, rather than just storing huge amounts of data. It's the connections that are as important as the data itself. Okay, so we've got a pretty good basis of graphs. Let's go back to retrieval augmented generation and have a look at how actually graphs can support us in providing context to our generative AI applications. So I think this is about the simplest architecture diagram I can draw for a generative AI application. So I have a user generates some input, a question. There is an application that has a prompt. The user's input and the prompt are meshed together, put together, sent to the large language model, and the response is passed all the way back. And very simply, when I did my surfer example, that's kind of what I was doing. I provided a prompt, I got some user input, and I sent that, and then I got a response back. But what we saw was the addition of context allows our applications to be more useful. Context being information that will allow the LLM to create a better response, right? And we have two things in order to be able to generate our context. We have the application's purpose, so what it's there to do. Is it there to talk about financial transactions in a bank? Is it there to talk about surf conditions? Is it there to help find documentation for a particular product? So we have the context of what the application does, and then we also have the user's input. And our job is to take that user's input and find the best data that we can provide as context in order to be able to give the large language model the information it needs to provide a good and accurate response. And a really typical way of doing that is through vector embeddings. So vector embeddings being, a mathematical representation, in this case of text, but of data. And we can use those vector embeddings to say, okay, well, I've got the user's input. If I create an embedding for that, find me the most similar data that kind of represents what the user's asking for. And vectors work incredibly well for when you are looking for sort of fuzzy matching, when you're sort of trying to find information that may be vague or open-ended. The example I've used here is, what does Paul Graham think about generative AI? And where vectors work really, really well, so let's say our data source is, a repository of AI blog posts, and we can use that input. What does Paul Graham think about generative AI? Use that repository of AI blog posts, find the ones that are most similar to the question that's being asked, provide that as context to our LLM, and we can create a decent context that allows our LLM to produce a response. However, vectors are ineffective for highly specific fact-based questions. So in this case, how many generative AI startups has Paul Graham invested in? So I'm looking for a number. I'm looking for a specific, value. And while that specific value may be in one of our data sources, one of our unstructured data sources, it's going to be difficult for the LLM to pick out the right number, or maybe it needs to do some addition to sum up some values, and that's where vectors fall down. And particularly, other aspects of things like specialist knowledge, when you're looking for something specific, you're not looking for that kind of fuzzy match. You're looking for something very, very, very specific. So if we go back to our architecture diagram, a way that we can help fill that gap, or a way that we can fill that gap, is through knowledge graphs. Again, connected data, allowing us to find facts about the information that we have been given. And I like this example. She's just a small town girl living in a lonely world. If I'm going to look to map that as a knowledge graph, I can use entities such as people, events, and locations. Small town boy took a midnight train going to location anywhere, was born and raised in South Detroit. So I can create a factual representation of unstructured data that's going to allow me to gain more specific answers to the questions that I'm looking for. Okay. Hopefully what we've started to see here is that if we're looking to provide information to our LLM to provide good responses, context is key. So here is a review, right? And this is a piece of text which is I think Neo4J is a great place to work. It's a review from a job site, and if we were to provide that as context to our LLM, a typical response would be, according to the provided context, Neo4j is a great place to work. I would like to prefix all of this with, I truly believe that Neo4j is a great place to work. But context is key. So let's sort of build that into a graph. So if that review was posted by a person who has the username Emil Efren, Emil Efren works at Neo4j. I know that Emil's my boss. In fact, Emil is my boss's boss's boss. So context is key, and providing our context through using GraphRAG, and by complementing whatever data we have with facts that we have from our knowledge graph, we can provide a better response. According to Emil Efren, the CEO, Neo4J is a great place to work. Right? Context is key. So let's just hop back to OpenAI, and we will look at another sort of demonstration. So I'm going to keep the same context that I had before. You're a surfer dude having a conversation about surf conditions. It's got exactly the same context. But I'm going to ask it a different question. So more sophisticated. Yeah. Where should I surf today? And it's going to use that context to provide me with some information that is based in the context that it has. So, dude, gnarly swells at Fistral, bro. We've got 6 feet waves with offshore winds, flat and calm. Fistral's the place to be. It is making a strong recommendation that 6 foot waves are better than 3, which they are. Offshore winds, good, fine. Go to Fistral. However, there could be very well context that we are missing here. And that's kind of what I want to do, is I want to add to this some context that I could get from a knowledge graph. So the context I'm going to add is data that we gained from our knowledge graph. This is a graph pattern. The parentheses represent nodes. The arrows and square brackets represent relationships. So in this, we can see there is a beach node that has the name of Fistral, and there is a relationship to a status that says Fistral is closed today. And there's also some additional information that says that Pole's F has an event later on where there is a party. So we have added some additional context through our knowledge graph. And again, I want to ask it the same question. Where should I surf today? Okay, so, well, dude, looks like Fistral's got some gnarly 6 feet waves, but it is closed today. However, Pole's F is flat and chill, but we've got a party cooking up later, so maybe that's the right place for you. So if you're up for some mellow action, Watergate Bay is where you should be paddling out. So it has used the additional context, the fact-based relationships to create a more specific, arguably better answer. And that's where GraphRAG comes in. It's about using graphs to generate facts that allow you to provide a better context. Okay, share this tab instead. So I just kind of wanted to finish off with, we talk a lot about GraphRAG, and for me, it falls into 2 very discrete things. So the first one is extracting entities and relationships from unstructured text. If you have a graph, or if you have good metadata that describes your context, you should use it and build a graph from it. You'll be able to query it quickly. You'll be able to understand those relationships. However, what you can also do with generative AI models is actually you can create your own knowledge graph from unstructured text. Small plug for Neo4J, there is a great tool called the LLM Graph Builder, which you can use to do exactly that. Provide it with some unstructured text, and it will create a knowledge graph for you. The second one is what we have been looking at, and the small demos that I've done is using relationships to provide context and answer questions to provide better responses. Okay, so right back to the start, graphs and GenAI. Like, why? Graphs are a really good way of providing context to your generative AI applications, and you can use generative AI as a way of generating your graphs to complete that cycle and to provide better context. All right, so thank you. I have enjoyed talking to you. I'm very pleased all the demos worked. Thank you very much. I hope you've enjoyed it as much as I have.